3 fair coins are tossed. What is the probability of getting at least one head showing? All right, so we're going to flip 3 coins, and we want to know not just what's the probability of getting one head, but at least one head. Now, at least, folks, means one or more to show. All right, so let's take a look at this one and see how it's going to work out down here on our paper here. So I like to use a tree diagram when we're dealing with probability, especially situations like this. It sometimes makes it a little bit easier to see what's going on, what is happening. And let's do so. Let's do so. Our first toss, okay, that's the first thing we want to do. We're going to have a first toss, and it's going to be an option of heads or tails. And I'm using a tree diagram. These are the branches. And so we got a heads and we got a tails. And the chance of getting a head is 1/2. It's 50-50, as we like to say, but 1/2 is the good fraction that goes there. You might use 5/10 or 0.5 if you are so inclined on your page there. I like 1/2 because they're easier to multiply by than 0.5s when we do this as much as we're going to do it today. Now let's go with our second toss. Now the second toss comes from the fact if you get heads, you're going to toss again, all right? Or your second coin is going to be working. So let's call it the second coin, or it could be the same one. It kind of gets confusing, doesn't it? Not necessarily. Think of these maybe like a dime, penny, and a quarter, or you can say, hey, we're flipping 3 at one time. It's going to be the same story. You're tossing 3. So anyway, the first one gets heads. Does that make any difference what's going to happen on the second coin? No, you've still got this situation of heads or tails. If you get a tail, you're going to have the same story again. You're going to have heads or tails. And once again, those options, the probability is still 1/2. Coin does not know it's supposed to do anything differently because it's not supposed to do anything different. It's random. It's a randomness here, all right? So then we've tossed 2. So let's go with the third coin, okay, or the third toss, however we want to look at that, all right? Let's go with it. Put heads to tails. Here we go again. Another head, tails. So see, now we've got 3 going here. We've got 3 working our way out. Again, we got 1/2, 1/2. Ooh, getting this one. It's getting a little jammed up here, isn't it? We got a heads and we got a tails. We got a 1/2 again and a 1/2. Let's see if I can bring that one out a little bit more there. Heads, tails. We'll go a 1/2 and 1/2. And finally, down through here, we'll have heads and tails again. It's still 1/2 and 1/2. You say, why'd you put all those things down there, Ernie? I think we need to lose our bottom third, guys, if you'll help me out there. All right, thank you. Well, for one thing, each of these tells us a journey. We have 1, 2, 3, and that one takes us out there as heads, heads, and heads, all right? So that's the first journey tail here, all right? Or journey trail, I should say. We're going to get a tail here in just a minute, all right? So we got heads, heads, follow this one. We got heads, heads, tails. All right? Follow again, we got head, tails, heads on this trail. And we can go along here, heads and 2 tails. Now that's 4 options right there. Now we've got the bottom branch of the tree, all right? The bottom branch down here of this diagram that we want to work through. So follow, here we start with tails, all right? So we're going to go tails, heads, heads, which is going to give us a THH. Move along here, we've got tail, heads, tails. Keep working. Tails, tails, and a head. And last but not least, oh, there's that tails, tails, and tails. Now put these 1/2s on here. They get messy, don't they? Sorry about that, folks. It got especially on that last round there, that last toss there. But what this symbolizes is first, second, third toss, okay, in each case here. And once again, they could be tossed at the same time, or I could have flipped one, come back, flip it again, flip it again. Fair coin means 1/2 probability on both heads and tails each time, each toss. So what's happening here, because these are independent, you've heard that word in your school days, probably independent events, we're going to actually multiply these probabilities. So to get a 1/2 times a 1/2 times a 1/2, that's going to force 1/8 to happen, all right? That's our probability of having 3 heads, all right? That's all showing, all right? Down here, we also have a 1/2 times a 1/2 times a 1/2, so we've got 1/8 the probability of getting 3 tails. Now, let's think about it. We could go and figure out all these tail trails here, heads and tails trails here. Boy, that sounds pretty good. They're all 1/8. They're all 1/8. There are 8 of them. They're all equally likely. And you can count up how many have at least one head. Well, that would be here, here, here. Anywhere there's 1, 2, or 3 heads, we're in business, all right? So there's 1, there's 1, there's 2, there's 1, there's 2, there's 2, and there's 3. So it looks like I have 7/8. I count them up. 7 times 1/8. I've got 7/8 going for me here, all right? Another option, some of you are saying, isn't there an easier way? Well, you could look at it this way. You know, this is where you have no tails, all right? Excuse me, no heads. You got 3 tails. And with no heads happening, it's 1/8. So you could also do 1 minus 1/8, which will get you back to the 7/8. Either way you do it, coming in the front door or maybe going in the back door, all right? You're going to get 7/8 both ways. A little bit of fun with probability.
For more math help, visit TNLearn.org.